Today, we will factor trinomials where the leading coefficient is not 1. Here's our vocabulary. In our trinomial, ax squared plus bx plus c, our a values can be a number other than 1. Whenever we have a trinomial where a is not equal to 1, we can use the grouping method. Here are our steps for factoring a trinomial where we have ax squared plus bx plus c. Let's do an example at the same time. 2x squared minus x minus 28. In order to factor this trinomial, we will first multiply the leading coefficient by the constant a times c. Our a times c in this case, 2 times negative 28 is equal to negative 56. Next, find the factors of multiplication of AC that add to the middle term, bx. Our middle term happens to be negative x, and we are going to factor negative 56 into two terms where I could do a positive 7 and negative 8. Positive 7 times negative 8 will give us negative 56. Positive 7 plus negative 8 will give us the bx, the negative 1. Separate the middle term bx. We're going to separate the middle term right here. I'm going to try to squeeze everything on the side. 2x squared minus x minus 28. I'll separate the middle term bx into two factors by using the numbers that we got from here. I will write 7x, positive 7x, and negative 8x. As you can see, a positive 7x and negative 8x are already added up, can add up to be equal to negative 1. So we are not changing anything from one step to the next. Here is my 28, here's my 2x squared. Next, group the first term together and then the last two terms together. This is the reason why this method is called grouping method. Here is my group, and I will, after grouping, we will find the GCF of each binomial. We have, in each group, we have two binomials. On each binomial, we're going to find the greatest common factor. Greatest common factor in the first group is x. Greatest common factor in the second group is f4, but because leading coefficient is negative, I'm going to factor out a negative 4. If we do our factoring in each binomial group, I will get x quantity 2x plus 7. On the second binomial, we will have negative 4 quantity 2x plus 7. At this point, we will do group one more time. One factor is common binomial, and the other is the sum of two GCFs. Here's my common binomial. I will factor that out one more time. So here's my 2x plus 7. Factor that one more time, and x is left from the first one, and then negative 4 is from the second one, and we are done with our factorization. Let's look at a couple more examples to review these steps. Here we factor the trinomial 8x squared plus 10x plus 3. Please look at our steps as we solve this question. First, multiply a and c. 8 times 3 is 24. This is the magical number that we've been looking for, and we are going to find factors of 24 that could add up to 10. Factors of 24 that could add up the middle number are going to be 6 and 4. We can separate the middle term into a 6x and 4x. We still have our plus 3, we still have our 8x squared. Those didn't have any changes, we just copied them down. Everything on the first row is equal to everything on the second row. We just separate the 10x into a 6x and a 4x. Because this 6x was a positive 6x, I will put a plus sign in front. Now we're going to group each binomial, first two term and the next two term, and we will factor out the greatest common factor in each binomial. On the first two term binomial here, our greatest common factor is 2x. On the second one, greatest common factor is 1. So I'm going to factor out 2x on the first group, which will give us 2x quantity 4x plus 3, and the second one I'm only factoring out a 1. After you get used to solving these, you don't have to write this 1, 4x plus 3. Now I need to factor my common binomial. This is my common binomial. If I factor that out one last time, 4x plus 3 is here, and 2x comes from the first one, and then the plus 1 comes from the second one. This is our final answer for our factoring. Now, let's do a quick check step as well. I can redistribute everything, and it should give me the first problem. Factoring and distribution, they are inverse operations of each other. 8x squared plus 4x plus 6x plus 3, and then 8x squared plus 10x plus 3. Yes, our check step showed that our factoring was correct. Here's it's nicely written. Let's do another example. Multiply a and c. 3 times 10 is equal to 30. Think about factors of positive 30 that could add up to a negative 17. That would be among all the factors of 30, we're going to find the ones that add up to negative 17. When I think of factors of 30, I know of 30 and 1, 15 and 2, 5 and 6. Those are the factors. 15 and 2 looks like is going to work in our case. Negative 15 and negative 2, because a negative times negative will make a positive 30, and negative 15 plus negative 2 is going to be equal to negative 17. We will separate negative 17 into two parts, negative 15x and negative 2x. We still have our plus 10, we still have our 3x squared. Now we are going to group first two terms and then next two terms. Among each group, we are going to factor out the greatest common factor. 3x is my greatest common factor. Negative 2 is my greatest common factor. I chose negative 2 because the leading coefficient in here is negative. As soon as I see that negative, I'm going to factor that out as well. Now, let's factor out the greatest common factor. Here's my 3x, x minus 5, my negative 2 factored out. Negative 2 divided by negative 2 is positive x. 10 divided by negative 2 is minus 5. Now, we are going to factor out the common binomial, which will be x minus 5 is the common binomial. We will have 3x coming from the first one and negative 2 coming from the second one, and we have found our solution. Here's my quick check step. X minus 5, 3x minus 2, distribute, 3x squared minus 2x minus 15x plus 10. 3x squared minus 17x plus 10. So this was my check step. Here's your U-try. Follow each step. Multiply your A and C, and then find factors of AC that could add up to B. Here's your second U-try. On this question, you might want to do 9x squared plus 0x minus 4. After you multiply a and c, the factors of AC must add up to 0. Here's our next example. I will first find my magic number by multiplying 9 and 4 together, which is 36. I know 36 has many factors, like 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Among all of those, we need to think about a factor, a pair of factors that could add up to 12. And it's easy to see that 6 plus 6 will make 12. I will separate it into a 6x and another 6x, and this is a positive 6x. I still had my 9x squared and plus 4. We are going to group the first two and the next two among each other. In the first two, we will find a greatest common factor. 3x is the greatest common factor between 9x squared and 6x. We will find the greatest common factor on the next group, which is going to be 2. Now we are going to factor out our greatest common factor from each group. We will have 3x quantity. If I factor it out, we will have 3x plus 2. On the second group, we have positive 2 factored out, and you will have 3x plus 2. One thing I can point out is that if you, after you factored once, if you see matching binomials, that's an indication that you're on the right track. Once you see matching binomials, you can combine, you can factor that out from these multiplication from each term. 3x plus 2 factored out from the first term, you still have 3x. And then from the second term, you have a positive 2. It turns out that our answer is 3x plus 2 times 3x plus 2, which would be 3x plus 2 squared. I can do a check step on this one too. 3x plus 2 squared is equal to 3x plus 2 times another 3x plus 2. I can do a distribution on here. Multiply, multiply. We will have 9x squared plus 6x plus 6x plus 4, which will be 9x squared plus 12x plus 4. And our check step shows that the answer is good. Our answer after factoring is going to be 3x plus 2 quantity squared. Here is your U-try. Multiply 4 and 15. Find factors of that multiplication which could add up to 16. That's pretty much it. In the class, we're going to work on more different type of examples of factoring trinomials. Please try to remember your steps of factoring trinomials.